Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this lecture series, we are going to discuss about grounding in electrical wiring and safety. First of all, what do you mean by grounding? Grounding in US or earthing in UK, it is a process of connecting electrical systems, appliances and metal enclosure to ground. Here ground refers to the physical connection to earth which act as a reference point and also a return path for current. Main purpose of grounding is to provide a low resistance path for electricity to flow. Here grounding can implement with the help of a grounding electrode. See the diagram. See, in grounding we have two parts. One is first part we have all the individual branch circuits consist of wire like ground wire that we connect to the metal frame of our outlet box, appliances in home and tools, etc. Here all the ground wires from individual branch it reaches the main circuit breaker panel and connect to the ground bus. This is our first part. Second part, grounding system consists of a large copper wire which is known as a grounding electrode that is connected to a ground rod which is buried into earth. Okay, types of grounding we have two types. One is low voltage systems, another one is high voltage systems. Here we have grounding arrangements like TN, TT or IT. Here the first letter indicates the connection between transformer and earth. Second letter indicates connection between electrical equipment and the consumer and earth. See here, second letter it indicates connection between the electrical equipment at the consumer and earth. Okay, and our first letter T direct connection to earth and I no connection with earth, and in the second letter T local earth connection and N electricity supplier provides the earth connection. While coming into high voltage systems, power generation stations, substations like that, it form a high voltage networks that are quite different from low voltage distribution. And here we prefer types of grounding like low voltage systems for home appliances and high voltage systems for power generation stations, substations like that. See here, types of low voltage grounding. We have TN grounding. In this TN earthing system, the star point of the transformer, which is neutral, is connected to earth and at the consumer side. The ground wire of electrical appliances is connected with this connection. See here, here we have two elements S and C. In this we have three types TNS, TNC, TNCS. TNS means the ground and neutral conductors are separate and are connected at the transformer. TNC, ground and neutral conductors are same. TNCS, separate ground and neutral conductors but only near the consumer side. TT grounding, in this type of grounding, the grounding at the transformer at the consumer are independent. And IT grounding, there is no grounding at the transformer, but there is a local grounding using a grounding electrode at the consumer side. So typically we have TN grounding, TT grounding, IT grounding. In TN earthing system, we have TNS, TNC, TNCS. C. Types of low voltage grounding. Your first one is TNC system. Here your voltage might be single phase or three phase, 230 or 400 volt. TNCS system, see the connection, and TNS system, TT system and IT system. Here you may have a single phase or three phase supply. Here the letter T direct connection to earth, I for isolated, N is neutral, S is separate and C for combined. Here PEN is protective earth plus neutral. Okay, types of high voltage grounding. Here we have three types of systems: ungrounded systems, resistance grounded systems, solidly grounded systems. See the diagram. Here in this diagram, a three-phase power supply is fed into transformer. Actually it has three phases. This three-phase current is used by the home appliances. In this part, grounding is preferred. Here we have two types. Here we have two types, which is mainly for home appliances, and also we have solidly grounded systems for large applications. So mainly we have high voltage grounding, three types of systems: ungrounded, resistance grounded, solidly grounded. See, in ungrounded systems, it is not really ungrounded. Electrically, the system is connected to ground through the capacitance between the lines and the earth, that is capacitance grounded system. See here, in ungrounded, it is we don't have any direct physical connection between any of the lines and ground. See here, see the diagram, probe or target capacitance. Here we use capacitance which is connected with the ground, no direct lines involved. Resistance grounded system, here resistance grounding is when a connection between neutral line and the ground through a resistor. This resistor is used to limit the fault current through your neutral line. If voltage doesn't change, then the current is dependent on the size of the resistor according to Ohm's law, V equal to IR. Advantages of resistance grounding. Here the current is neutral. Instead of negligible, system over voltages are controlled with the help of resistance grounding. Here the reduced voltage and current which reduces heat. And the important point is to keep our motors safe, we use resistance grounding. The reduced currents also reduce the risk of shock and flash or blast hazards. Types of resistive grounding, we have high resistance grounding, low resistance grounding. See, high resistance grounding, see here, it is typically used to limit ground fault current to less than 10 amps. Here the low current will not trip your protective devices during single line to ground fault. See, high resistive grounding, low resistive grounding, it is typically limit the current between 100 to 1000 amps. Here the low resistance grounding also reduces over voltage and is used in medium voltage systems of 15 kilovolt or less. Typically watt-bit generators or motors are used. See here we have phase A, B and C, and also we have neutral line which is connected with the load. Here the low resistance grounding systems that uses current between 100 to 1000 amps. Solid grounding is connect without any sort of resistance in the way. Solid grounding has two main uses. One is in systems with voltages 600 volt or less, solid grounding can be used if it is not necessary to maintain operation of a faulted circuit. Okay, here in solid grounding, the grounding is typically connected to the system at a neutral point like neutral terminal of a generator or transformer. If systems of 15 kilovolt or greater, solid grounding can be used. If high ground fault, the currents are desirable of any reason such as quick ground fault conditions like that we are using here. Thank you. I think we'll get a clear understanding about grounding in electrical wiring and safety. Thank you. Thank you. Thank you for watching.